Please welcome Food Computer Program founder, Melanie Shimano.
A few years ago, I watched this incredible TED Talk where the speaker talked about transforming our food systems with computer programming and robotics at a local urban agriculture level with an open source technology they called the personal food computer. And if you're at Red Hat Summit in 2017, you might have seen Caleb Harper talk a little bit more in depth about what he and his team at the MIT Media Lab are doing with food computers and how they wanted to use this to change the food landscape, especially as the average age of the farmer continues to increase. And to also help people get more interested in learning about plant characteristics and how we can grow food in creative spaces. A food computer so controlled that it kind of crawls out by itself. How we can use it to grow food in creative spaces, and how we can use this to address building a collective force around tackling this issue of solving a global population that's expected to increase to about 10 billion people who mostly live in urban areas in the next 30 or so years. And so living in Baltimore, I was pretty familiar with food systems challenges. 1 in 4 Baltimore City residents lives in a food desert or a healthy food priority area, which means people don't have regular access to grocery stores or outlets for healthy food. This obviously causes a problem for people's everyday lives, and it affects communities disproportionately that are lower income in African American communities. And it also gives rise to larger health problems, such as increasing rates of heart disease and diabetes. And in my experience in entrepreneurship and engineering, I knew that new technology could exponentially improve and help scale solutions to civic challenges, but really only if those solutions were founded upon true community needs and input. So I founded the Food Computer Program in Baltimore City Public Schools. It's a program that's aimed at encouraging students to use technology effectively in building and designing solutions for community challenges. And so in student science classes, we learn the basics of computer programming, urban agriculture, engineering, human-centered design. We use those concepts and build food computers. And then we talk about how we can use this technology and similar technology to implement solutions to things that happen in their day-to-day lives. So what's a food computer? I've mentioned it a few times, but as you can see, it's essentially a box that is climate controlled with computer programming and robotics. So we try to control the climate inside for the hydroponic system where plants are growing inside. So we're using water and not soil, as you can see from the camera. That'll show it. So there are a few different iterations of the personal food computer from the open source community, but the version that we build is essentially this box with a basin that has the hydroponic system, the plants in there, and then we have grow lights, a temperature sensor, and a fan that are all powered with a Raspberry Pi and Python code. So it sounds a little bit futuristic, but it's pretty simple, and especially due to the open source nature, it's actually much simpler than it sounds. So this is essentially what it looks like in a diagram. So we use Raspberry Pi as kind of the brain of the operation, and then we use other components, and we're essentially trying to mimic an outdoor environment inside this box to help plants grow. So what's the most important thing for a plant to grow is lights, obviously. And the cool thing about the food computer setup is that we're using all these components that are kind of like the basics of physical computing with a Raspberry Pi and using it and combining all these elements together. So we have code that's a simple like hello world of Raspberry Pi, which is how to turn on and off lights to mimic sunlight in daylight. So we can use this code to turn the light off if we want it to be nighttime. And then we use similar code to turn the lights on, again, to mimic daytime. So we can say, oh, we want to have a 14-hour day, a 20-hour day, a 5-hour day, and see how the plants react to that. And similarly, we have a temperature sensor inside, and different plants want different types of temperatures to grow in. And so we have that connected to a fan. So if we want the temperature to get a little bit warmer, we can turn the fan off. It takes a little bit of time to turn it down, but essentially, because of different environments, the lights kind of add some heat, the outdoor environment adds a little bit of heat, and so we might want to cool it back up again. So we run a similar code and just turn it back on. And basically are trying to regulate that temperature inside of it. So as you can see, we use all these like very simple components, and beside each of them, apart from each other, are pretty simple. But when we combine them, we get this food computer that's essentially this like really cool open source project and something that we can make some real things with. So we obviously are growing food inside of it, we can use it to cook with, and we're able to see how we can use technology to do real things. So students, despite never having written computer code before, build these and use the code and write the code with them all by themselves. And through our different builds and exploration of these food computers, we've been able to learn some coding and agriculture best practices from the folks at the MIT Media Lab and the open source community that spun out of it, as well as other educators around the world to improve our own food computer systems and better understand how we can use that to improve stuff that we're doing in Baltimore. So for example, we're trying to learn how to control algae growth within these hydroponic basins and how to grow root vegetables like carrots if we're using hydroponics instead of soil. So making the technology hands-on and easy to build on not only shows students what the technology can do in a real-world setting, but it also makes the technology more accessible and easier to build upon using their own expertise in urban agriculture and better understanding how they can improve their school, cities, and neighborhoods using more than just technology. So for example, after we built some of these food computers, students built their own versions of the food computers and designed them how they wanted to. They built out a room-sized food computer that holds kind of like 300 plants. They led coding workshops for middle school students in the local community. They ran a breakfast sandwich business because we'd done so much cooking with the vegetables that we'd grown in the food computer class. And they were able to run a pop-up restaurant at a local food hall in the city using the plants that we grew in the food computers to make basils and chimichurri sauce for the sandwiches that they sold. So yeah, the open source tech allowed students to create some really cool food computers and learn about technology, but I think more importantly, it really expanded their worldview and showed the students how they could have an impact on it. And if we're trying to make our cities and neighborhoods smarter and easier to live in by incorporating new technology, why not teach our future leaders how the technology can be used to their advantage, and then have them tell us how they want to incorporate it instead of transplanting talent around the globe to keep up with this changing technology. So if we use an open source technology model as a default for training and collaboration and new project implementation, it can help create a more inclusive and expansive future where students are growing up to build the technology that complements solutions to these community challenges. In a future where, hopefully, I can see my students on the TED stage doing the same. And you can see these students, Tim, Zaire, and Ariel, doing that and how that's actually playing out right now in the class in the new open source stories film, which premieres tonight at 4:30. Thank you.